Hi everyone. In this set of videos, we're going to mainly talk about Chapter 3, but I'm also going to tie in a lot of ideas that we learned in Chapter 2. In the first video, we're going to talk about the measures for the center. In the second video, we're going to focus on the standard deviation, but that's a measure for the spread. And we'll talk about the IQR as well later on. That's another measure for the spread. We're going to talk about the empirical rule and z-scores, and we're going to bring everything together to describe a distribution, and then finally talk about outliers and box plots. So before we get started with talking about the best measures for this measure for the center, I want to look at the big picture of how we're going to bring this information together. So we're going to look at the big picture, then we'll talk about the details, and then we'll come back to the big picture. In Chapter 2, you learned about displaying data. So when it was qualitative data, you could do pie graphs or bar charts. When it's quantitative data, you can do histograms, dot plots, or stem and leaf diagrams. When we look at displays for quantitative data, we want to be able to describe that distribution or describe the display. And there are three aspects that we look at. We look at the shape, the center, and the spread. We talked about the shape in Chapter 2. We talked about symmetry versus skewness and whether or not something's skewed right or left. We also talked about modes, unimodal, bimodal, uniform. We also talked a little bit about unusual features, but the main unusual feature that we usually want to discuss are outliers. And we actually won't get to a formula for outliers until we get to section 3.3. So that's coming near the end when we talk about box plots. So in Chapter 3, we're going to move on and discuss the center and the spread. The center will be section 3.2. The spread, when you talk about the range and the standard deviation, these are 3.1. Let's try that again. Where's my eraser? This is 3.1. It's the spread that comes in section 3.2. And then we'll also talk about another measure for the spread, the interquartile range, which comes along with box plots. So this is from section 3.3. We will have other ideas and skills within these sections, the empirical rule, z-scores, things like that. But when it comes to describing a distribution, this is kind of where everything is with that skill. So let's start off by talking about the center of a distribution. We have the choice between two measurements, the median and the mean. The median is the middle data value. So half the values are below the median and half the values are above the median. So it is directly in the center based on how many values there are. The mean, on the other hand, is the average. We add up all the values and divide by the number of individuals. The mean feels like the center because it's the point at which the histogram is balanced. Sometimes the mean and the median are very close, and sometimes they're very far apart. So depending on the shape of the distribution, we will talk about one or the other of these as being the best measure for the center, or the best description of the center. In the textbook, they talk about how to calculate these, but finding these statistics, we're going to use our calculator for that. What's more important is being able to interpret these statistics and knowing when to use which one. So in order to talk about when to use either the mean or the median, we need to talk about what it means for a statistic to be resistant. So if a statistic is resistant, it means that it's not affected by extreme values. It's not affected by outliers. A median is resistant, whereas a mean is not. And I have an example to show why. But figure if the median is the middle value, it doesn't matter how big or small any extreme values, meaning the max or the min is, the median is still in the center. However, the mean, because of the way it's calculated, because you add up all those values, when you add an extreme value, it's going to affect the mean when you add them up and then divide by that number of individuals. So here's an example. It says 5 families have annual incomes of $25,000, $31,000, $34,000, $44,000, and $56,000. One family whose income is $25,000 wins a $1 million lottery, increasing their income to $1,025,000. So we want to look at the mean and the median of this distribution before the lottery winning and after the lottery winning. So again, our distribution is this before this family wins the lottery. And so when we look at the mean is 38,000 and the mean is 34,000. They're very close to each other. So really either one is probably describing this distribution equally well. But when we have an outlier, meaning that this 25,000 became 1,025,000, and then we again make the calculations between the mean and the median, you can see that the mean is greatly affected by that outlier, whereas the median was only slightly affected. And this is why we say the median is resistant to this big outlier, whereas the mean is greatly affected by outliers. So what does this mean? This means that when you have a distribution that's symmetric, that means that you don't have any outliers. Then the mean and the median are the same. Whereas if we have a distribution that's skewed or has outliers, the median or the mean is being pulled in the direction of that outlier or skew, and therefore is being affected by it. So when a distribution is skewed, we would choose the median as the best measure for the center. When a distribution is symmetric, we choose the mean as the best measure of the center. And I think a valid question is, why the mean if both the mean and the median are the same? And the answer to that is because with distributions that are unimodal and symmetric, we have other things that we can look at, like the empirical rule and z-scores. And both of those use the mean in their calculations. So when we have this bell-shaped curve to our distribution, we like to talk about the mean. But if it's skewed to the right or skewed to the left, our best measure for the center is the median. And you can see here, if I ask a question about a distribution that's skewed to the right, and then I say, which value is greater, the mean or the median? Well, we'd say the mean is being pulled to the right, so the mean will be greater than the median for this distribution.